Welcome to qnawire.
All right, in this problem, we are looking at pacemakers. It says heart pacemakers are often powered by lithium-silver chromate button batteries. The overall reaction is given here. I did not include the states, but the rest of the reaction is here. Question A says that lithium metal is the reactant at one of the electrodes in the battery. Is it the anode or the cathode? All right, so let's start by reminding ourselves what happens at the anode and what happens at the cathode. The little trick that I use to remember it is consonant, consonant, vowel, vowel. So the reduction occurs at the cathode and oxidation occurs at the anode. So what we need to figure out is whether lithium is being oxidized or reduced. So to do that, we look at our oxidation numbers. Here lithium is all by itself, so it has an oxidation number of 0, and silver is the same way over here. I guess I really don't need to look at lithium right now, though. Over here, lithium is part of a compound, an ionic compound, and it's charged, therefore its oxidation number is +1. So lithium is going from 0 to +1. It is losing electrons, therefore it is being oxidized. And because it is being oxidized, that means that lithium is at the anode. Part B, choose the two half reactions from Appendix E that are most closely approximate the reactions that occur in the battery. What standard EMF would be generated by a voltaic cell based on these half reactions? So the two half reactions in Appendix E that were the closest were the lithium going, and that was lithium +1 electron going to just lithium metal. So that's essentially this reaction backwards, but not as it would be as part of chromate, just as a lithium ion. And the E cell, or the EMF for that was -3.05 volts. And then the other reaction was Ag2 CrO4 plus 2 electrons yields 2 Ag plus CrO4 minus 2 minus, and that had an E naught of 0.45 volts. Remember, this was the oxidation, so this must be the reduction reaction over here, and E cell is equal to the E for the reduction reaction minus the E naught of the oxidation reaction. So that would be the 0.45 volts minus the -3.05 volts to give a E cell of 3.5 volts. Part C says the battery generates an EMF of +3.5 volts. How close is this EMF to the one calculated? They're the same. So we were able to calculate the exact same EMF as was actually produced. And then part D, calculate the EMF that would be generated at body temperature. So we're looking at 37 degrees Celsius here. How does that compare to the EMF that you calculated in part B? So you could go and try to use the Nernst equation, but basically that's not a very big change in temperature, especially when often we're looking at temperatures, absolute temperatures. The E naught is based on 25 degrees Celsius, and that's just not that big of a difference. So you can assume that E cell is very close to standard E cell. Therefore, it should be very close to 3.5 volts.